It drifts in from the absolute darkness. From a chasm of space so profound and empty, our concepts of distance and time dissolve into meaninglessness. This traveler has known only the silent, unending night between the stars. For millions of years, perhaps hundreds of millions, its journey has been a solitary pilgrimage through the galactic void, a frozen ghost moving through a cosmic graveyard. It is an emissary from a place we will never see, a physical relic of a solar system we do not know, a whisper from a distant alien sun, and now it has breached the borders of our own celestial home. It is a trespasser, an interloper, a castaway from another world, and it is moving with an urgency that defies the familiar, gentle rhythms of our own solar system. It is a shard of another reality, and it is here now falling toward our sun with astonishing, impossible velocity. This is the story of a comet from beyond. On a cool, crystalline night at an observatory perched high in a remote mountain range, the world is asleep, but here the universe is just waking up. The air is thin, the silence broken only by the near inaudible hum of cooling fans, and the slow, majestic groan of a telescope dome rotating. Inside, an astronomer sits bathed in the soft red glow of monitors, staring at streams of data pouring in from the sky. The work is methodical, often tedious, a search for the unusual amidst a torrent of the utterly predictable. Night after night, the same starfields are scanned, their movements mapped with precision, any change catalogued by automated software. But tonight the software flags something, an anomaly, a single point of light fainter than a firefly a mile away that should not be there. The astronomer leans in their mind, quickly running through the possibilities. A satellite glinting in the sun, an asteroid missed by previous surveys, a flaw in the imaging sensor. The initial reaction is not excitement but professional skepticism. The universe is filled with false alarms. They pull up the archival data from the previous night and the night before. There it is again, a ghost on the film. The object is moving, but it is the way times it is moving, that sends a jolt through the quiet calm of the control room. It is too fast. Not just fast in the way a near-Earth asteroid is fast, but fast in a way that seems to violate the very architecture of our solar system. The astronomer plots the trajectory, a simple arc on the screen. The line is not a gentle, closed ellipse, the familiar loop of a planet or a comet bound to our sun forever. It is not even a parabola. The shape is a hyperbola, a stark, open-ended slash across the heavens. This is the geometric signature of an outsider. An object not born of our sun, not a member of our family. It is a visitor moving with such tremendous momentum that the sun's gravity, the most powerful force in our neighborhood, cannot hope to capture it. It will curve around our star in a magnificent fleeting embrace, and then be flung back out into the interstellar darkness, never to return. The astronomer's heart begins to pound. They check the calculations again and again. The numbers are unassailable. This is it. An email is drafted, its subject line written in the clipped, urgent language of discovery. Alerts flash across secure networks, waking up scientists in different time zones. The world's great telescopes begin to turn one by one like colossal eyes opening to stare at the newcomer. To truly grasp the significance of this celestial guest, we must first understand the invisible architecture that governs our cosmic home. Imagine our sun not as a ball of fire, but as a heavy bowling ball placed in the center of a vast stretched rubber sheet. Its immense mass creates a deep depression, a gravity well. The planets, like smaller marbles, roll along circular paths within this well, trapped in stable, predictable orbits for billions of years. The comets and asteroids of our own system are like handfuls of gravel sprinkled onto this sheet. Some circle in the main depression with the planets. Others follow long, stretched-out paths, as if someone rolled them gently from the very edge of the sheet. They fall inwards, loop around the bowling ball, and then climb almost all the way back out before gravity pulls them in again in cycles lasting thousands of years. But they always come back. They are bound. They are part of the system. Their total energy is negative. They owe a gravitational debt to the sun they can never repay. An interstellar object is something entirely different. It is not a marble that started on the rubber sheet. It is a projectile fired from an immense distance from times another times rubber sheet belonging to another star entirely. It arrives with so much kinetic energy, so much velocity of its own that it screams across our celestial fabric. It feels the pull of our sun's gravity. Well, yes, its path bends, it deviates, but it possesses what is known as positive total energy. It has more than enough speed to escape. It pays no tribute to our star. It is a tourist, not a resident. It is merely passing through, and our sun's gravity is not a tether, but a temporary diversion on an infinite journey. This is what that hyperbolic trajectory signifies. The signature of a traveler with enough velocity to defy the bonds of solar gravity, a cosmic vagabond free of allegiance to any single star. As observatories around the globe focused their attention, the data began to reveal the intruder's extraordinary nature. Its velocity, when measured far from the sun's influence, was an astonishing 134,000 miles per hour. Let us pause to consider that speed. It is a figure so large it borders on the abstract. A commercial jetliner travels at about 600 miles per hour. A rifle bullet about 1700. The fastest crewed vehicle in history, the Apollo 10 capsule, reached a blistering 25,000 miles per hour during its return from the moon. This cosmic interloper is moving more than 5 times faster than that. If it were to travel across the continental United States, its journey from New York to Los Angeles would take just over 1 minute. This is the velocity of something that was not nudged from a nearby perch. It was violently ejected from its home system and has been accelerating through the galaxy for untold millennia. This visitor was not the first of its kind. In 2017, humanity had its first confirmed encounter with an interstellar object. It was named Oumuamua, a Hawaiian word meaning a messenger from afar arriving first, and it was profoundly strange. It was small, no larger than a city block, and appeared to have a bizarre, highly elongated shape, perhaps like a cosmic cigar or shard. But its most baffling characteristic was its motion. As Oumuamua swung past the sun, astronomers watched it accelerate, moving away faster than gravity alone could explain. It was as if a tiny unseen rocket engine was firing. Normally for a comet, this is expected. As a comet nears the sun, its ices turn to gas, creating jets that propel it like a thruster. This process, known as outgassing, creates a visible atmosphere and tail, a coma. But Oumuamua had no visible coma, no tail, no dust. It was accelerating silently, mysteriously. The enigma sparked a firestorm of debate. Could it be an object made of something we'd never seen before, like a solid hydrogen iceberg whose outgassing would be invisible, or perhaps a nitrogen iceberg, a chip off a Pluto-like planet from another star system? Then came the most sensational hypothesis, championed by Harvard astronomer Avi Loeb. What if it wasn't a natural object at all? The shape, the lack of outgassing, the acceleration, all were consistent with a thin light object being pushed by the pressure of sunlight itself. A solar sail. And solar sails, at least in our experience, are not made by nature. The idea that our first interstellar visitor might be a piece of alien technology, a probe, or perhaps just space debris from another civilization, was electrifying, though it remains a fringe view within the scientific community. Oumuamua was a cosmic riddle that flew by too quickly for us to solve, leaving behind more questions than answers. Then, just 2 years later, a second visitor arrived, 2I Borisov, and it could not have been more different. Discovered by amateur astronomer Gennady Borisov, this object was in many ways exactly what scientists had expected an interstellar comet to be. It was large, and as it neared the Sun, it sprouted a magnificent coma and tail, behaving just like the comets from our own Oort cloud. It was a comforting confirmation that the universe at least sometimes plays by familiar rules. Spectroscopic analysis of Borisov's coma revealed its chemical makeup. It was rich in carbon monoxide, far more than any comet from our own system. This one chemical detail was a profound clue. It suggested that Borisov formed in a very different environment from our own comets, perhaps in the frigid outer reaches of a planetary system orbiting a cold red dwarf star where carbon monoxide could easily freeze solid. For the first time, we held in our hands, or rather in our light detectors, a chemical fingerprint of the building blocks of a planetary system light years away. And now we have this third messenger, not the bizarre enigma of Oumuamua, nor the comforting familiarity of Borisov. This new object presents a fresh and compelling new personality. The latest images composites painstakingly assembled from hours of exposure time by the Hubble Space Telescope and the James Webb Space Telescope are breathtaking. Hubble, seeing invisible and ultraviolet light, captures the ghost of the coma, a vast diaphanous cloud of gas and dust stretching for tens of thousands of miles. It glows with a faint ethereal blue-green hue, the telltale sign of cyanogen and diatomic carbon molecules being fluoresced by the sun's radiation. Delicate streamers and jets are visible within this cloud, faint structures hinting at active vents on the surface of the unseen nucleus, spewing material into space as the alien ice heats up. But it is the James Webb Space Telescope that has provided the most revolutionary view. Webb sees the universe in infrared light, the light of heat. This allows it to pierce through the glare of the dusty coma and study the material being released with unprecedented clarity. The first spectra from Webb were a revelation. Like all comets, this one is rich in water, but the analysis revealed a curious anomaly in the type of water. It contains a significantly higher ratio of heavy water, where one of the hydrogen atoms is replaced by its heavier cousin deuterium. This deuterium to hydrogen ratio is a crucial cosmological fingerprint. It tells a story about the temperature and conditions of the environment where the object formed. The ratio in this new visitor is unlike anything found in our solar system. It suggests it was born in a protoplanetary disk that was far colder and perhaps chemically different from the one that gave birth to Earth and our own comets. We are looking at water from another star. To understand what we are seeing, we must journey into the heart of the light itself. Imagine light from the sun traveling millions of miles, striking the comet, and then reflecting for millions more to reach our telescopes. As that light passes through the gassy envelope of the coma, the molecules within it behave like microscopic tuning forks. Each type of molecule, water, carbon dioxide, ammonia, absorbs very specific frequencies, very precise colors of light that correspond to their unique vibrational energies. When the collected light is passed through an instrument called a spectrograph, it is spread out into a rainbow, a spectrum. But this rainbow is flawed. It is riddled with dark, narrow lines like a barcode. Those missing slivers of light are the fingerprints. They tell us with astonishing certainty exactly what the coma is made of. It is a form of cosmic alchemy, decoding the substance of an object we can never touch, a messenger whose message is written in the language of missing light. The Webb telescope has even detected the faint signatures of complex organic molecules, carbon-based compounds that are the building blocks of life as we know it. Are they the same amino acids and PAHs found in our own meteorites, or are they subtly, alienly different? The analysis is ongoing, but each new piece of data is a new page in a book we never knew existed. With every new piece of information, the desire to know its origin intensifies. Where did this cosmic shard come from? What star system was its home? This question launches one of the most ambitious forensic investigations in modern astronomy. Using the precise measurements of the comet's trajectory, astronomers can digitally rewind its journey. They can trace its path backwards in time, out of our solar system and into the galaxy. But this is no simple task. Once it leaves the sun's immediate influence, its path is subtly bent and shaped by the gravity of other stars and the gentle but persistent tidal pull of the Milky Way galaxy itself. The calculation is a monstrously complex problem in celestial mechanics. The key to solving it lies in a revolutionary map of our galactic neighborhood, the data from the European Space Agency's Gaia mission. For years, the Gaia spacecraft has been scanning the sky, measuring the precise positions, motions, and distances of over 1 billion stars. It has created the most detailed, three-dimensional moving map of the Milky Way ever conceived. Astronomers can now take the calculated outbound trajectory of our interstellar visitor and cross-reference it against this extraordinary stellar database. They are looking for a close encounter, a moment in the distant past, perhaps 1 million years ago, when the comet's path intersected with the vicinity of another star. The search is on. Supercomputers churn through the possibilities, comparing vectors, probabilities, and timelines. Early results have pointed to a tantalizing candidate, a star system roughly 17 light-years away in the direction of the constellation Ophiuchus. It is a young star, barely a few 100 million years old, surrounded by a turbulent, dusty disk of debris, a planetary system in the chaotic throes of formation. Our models of such systems predict they are cosmic billiard tables. Newly formed gas giants with their immense gravity migrate through the disk, flinging smaller, icy and rocky bodies in all directions with unimaginable force. Most are sent into the star or into stable orbits, but some are ejected, entirely launched into the void with enough speed to escape their star's gravity forever. It is a violent, chaotic process, but it may be the galaxy's primary mechanism for populating interstellar space with wandering objects. Let us imagine that world. A brilliant, fierce young sun, much more active than our own. Orbiting it, colossal planets carve paths through a thick, primordial soup of dust, gas, and ice. Further out, in the frigid darkness, trillions of icy bodies like the one now visiting us coalesce. One of these bodies, a pristine ball of alien ice and rock, finds its orbit disturbed by the gravitational nudge of a migrating giant. It is pulled inward, then whipped around the massive planet in a gravitational slingshot. The encounter accelerates it beyond its home star's escape velocity. It is cast out a planetary orphan to begin a lonely journey that will last for millions of years and span quadrillions of miles. It tumbles through the dark, its surface frozen to near absolute zero, preserving within it a perfect chemical sample of the nebula that gave it birth. Eon after eon passes in silence. It drifts through vast clouds of interstellar gas past the light of countless nameless stars. And then, by sheer dumb luck, its random walk through the galaxy brings it on a collision course with the gravitational field of a modest yellow star in a quiet spiral arm. Our sun. After an unimaginable journey, the castaway has found a momentary harbor, and we are here to witness its arrival. The presence of these visitors forces us to reconsider One of the most profound questions ever asked: are we alone? For decades, that question has been framed by the search for signals for radio transmissions from intelligent civilizations. But these interstellar objects suggest another possibility, a theory known as panspermia. The idea in its simplest form is that life itself, or at least its fundamental building blocks, may not have originated on Earth. Perhaps it travels between the stars, piggybacking on cosmic messengers like this comet. The building blocks of life, amino acids, nucleotides, have been found in meteorites from our own solar system. We now know that these compounds are common in the universe. Could a comet like this, ejected from a world where life had already begun, carry viable microorganisms across the interstellar gulf? The journey would be perilous. The microbe would need to survive the initial violent ejection from its home system. It would then have to endure millions of years of exposure to the hard vacuum of space, the sterilizing radiation of galactic cosmic rays, and the profound, cell-shattering cold. Finally, it would need to survive a fiery entry into a new planet's atmosphere, or be part of an impact that delivers it to a welcoming new home. The odds against survival are astronomical. But the universe is a place of astronomical numbers. With trillions upon trillions of these objects potentially roaming the galaxy, the improbable can become the inevitable. This new comet is being intensely scrutinized for biosignatures, complex organic molecules whose structure might hint at biological processes. Finding such a signature would not be proof of alien microbes, but it would transform the panspermia hypothesis from a fringe speculation into a leading avenue of scientific inquiry. It would mean that solar systems are not isolated biological islands, but part of a great cosmic archipelago connected by a slow, patient tide of icy couriers. The seeds of life may be a galactic resource sown far and wide. This discovery, and the ones that will surely follow, are changing our very perception of the cosmos. We once thought of our solar system as a discrete, self-contained unit, an oasis separated from other stars by an impassable desert of empty space. We now see that the desert is filled with travelers. The galaxy is not a collection of isolated points of light. It is a dynamic, interconnected system that has been exchanging material for billions of years. Some of the very atoms in your body might have originated in the nebula of another star delivered to our own primordial cloud long ago. These comets are not just visitors. They are proof of a galactic ecosystem. We are breathing the dust of other suns. The era of one-off discoveries is ending, with new observatories like the Vera C. Rubin Observatory coming online, which will scan the entire sky every few nights. We expect to find not one or two interstellar objects, but dozens, perhaps hundreds. We will move from the study of curious anomalies to the realm of statistics. We will be able to categorize them. Are the strange rocky objects like Oumuamua common, or are the conventional comets like Borisov the norm? Does each star system produce its own unique flavor of ejected material? By studying a population of these messengers, we will be able to conduct a grand survey of the raw ingredients of planetary systems across our corner of the galaxy. It is a new window into the universe, a way to study alien worlds without ever leaving our own cosmic backyard. As the comet continues its inexorable fall toward the Sun, it will grow brighter and more active. It will reach perihelion, its closest approach, in a few months, swinging around our star in a gravitational hairpin turn. Then its journey will continue, carrying it back out into the void, its speed only slightly altered by its encounter with our Sun. It will fade from our telescopes, eventually becoming another undetectable point of light against the infinite black. But it will leave a permanent mark on us. It is a message in a bottle thrown from an unknown shore. We cannot read the entire message yet, but we have deciphered a few crucial sentences. They speak of a universe more connected, more dynamic, and more mysterious than we ever imagined. This silent, frozen traveler reminds us that the darkness between the stars is not empty. It is filled with the ghosts of lost worlds, with the messengers of other suns, and with the tantalizing possibility that we are part of a story far grander than the one contained within the confines of our own pale blue dot. The night sky will never look quite the same again.
But ahead lies a void so massive